Welcome. Today, we are going to talk about sculpting AI. We're going to move way beyond those basic off-the-shelf models and really dig into the techniques that let you tailor them, making them smarter, way more efficient, and, uniquely yours.
Okay, so you've got this powerful general-purpose AI. It's impressive, right? But here's the thing. Out of the box, it just doesn't get the unique language of your business, your industry, or the specific tasks you need it to do. To get real, tangible value, you have to transform it from a generic tool into a specialized expert. And that, my friends, is exactly where customization comes into play.
All right, our first stop on this journey is the most fundamental method of all, full fine-tuning. Think of this as the most direct way to give your AI a complete personality transplant, one that's designed specifically for your needs.
So how in the world does this work? Well, by feeding the model a curated set of your own high-quality examples, you are literally changing its internal wiring, all of its weights and biases. And this isn't some temporary patch or a quick fix. You're creating a brand new, specialized model that has permanently learned a new way to behave, whether that's speaking in complex legal jargon or adopting your company's very specific brand voice.
Now, it's absolutely crucial to understand the difference between changing a model's behavior versus just giving it knowledge. As you can see, fine-tuning is all about changing the model's style and how it acts. It's like teaching it a skill for life. This is totally different from a technique like Retrieval-Augmented Generation, or RAG, which just hands the model some external info for a single question. The best analogy? RAG is like an open book exam. The info is useful for that one test, but it's not permanently learned.
But, and there's always a but, right? Here's the catch. Rewiring an entire AI brain, as you can probably imagine, is not cheap, not at all. Full fine-tuning can be incredibly expensive and requires a massive amount of computational power. So, while it's super powerful, it's just not always practical. And that challenge is exactly what led to some much smarter, more efficient solutions.
So if full fine-tuning is too expensive, how do we get around that cost? Well, meet LoRA. It's a brilliant technique that offers a much lighter and, frankly, a much more efficient path to customization.
LoRA basically works like a plugin or an adapter that you just layer right on top of the original model. So instead of trying to overhaul the entire engine, you're just adding a small, targeted component. This little adapter contains just a tiny fraction of the model's total parameters. And here's the magic. Those are the only ones you actually need to train.
The whole process is actually pretty elegant. First, you freeze the huge pre-trained model. You lock it down so none of its core wiring can change. Then, you attach these small, trainable LoRA adapter layers. And finally, you train only these lightweight adapters on your custom data. The result? You get that customized model behavior you wanted, but without the massive cost of a full fine-tune. It's a game changer.
Okay, but what if you want the power of a giant model, but you need it in a small, fast, efficient package? Well, that brings us to our next amazing technique, distillation.
Distillation is this really fascinating teacher-student process. You take a huge state-of-the-art model, that's your teacher, and you use it to train a much smaller, more economical student model. The whole goal is to transfer the sophisticated smarts of the big model into the little one.
So here's how that knowledge transfer actually happens. The big teacher model generates a perfect data set of questions and answers, basically showing off its expert style. The small student model then studies this data and nothing else, learning to perfectly mimic its teacher. The outcome is a nimble, cost-effective model that can perform tasks with the sophistication of a model many, many times its size.
So, we've walked through three really powerful methods: full fine-tuning, LoRA, and distillation. But the big question remains: how do you choose the right one for your specific job? Let's break it all down.
This table really brings it all together. You'd go for full fine-tuning when you need a deep, permanent shift in behavior and, frankly, when you have the budget for it. It's high cost, but it's also high impact. LoRA, on the other hand, is your go-to for an efficient, low-cost way to just tweak a model's behavior using that lightweight adapter. And finally, you'd choose distillation when your main goal is to create a small, fast, and cheap-to-run model that punches way above its weight class by learning from a bigger, smarter teacher.
And there you have it. We've gone from the brute force power of full fine-tuning to the surgical precision of LoRA and the clever efficiency of distillation. You now have a clear blueprint for transforming a generic one-size-fits-all AI into a highly specialized assistant that really works for you.
Which, of course, leaves us with one final and really exciting question. You're no longer just a user of AI.
You are its architect. You've got the tools to shape its mind, to mold its behavior. So now that you can actually sculpt your AI, what are you going to build?